So now we're solving the system of linear equations. So this is our system, and we got to figure out how we want to solve this. Well, when I look at the two equations, the easiest one to eliminate will be to change this one, the top one, because it only has one x, and this has 7x. I could multiply the top by -7, and when I went to add them, they would cancel. This over here, we have an 8 and a 7. We'd have to multiply both equations by a number, which is a little more complicated. So the first thing I'm going to do is I'm going to multiply this equation by -7. So that'll get me -7x minus 56y is equal to -112. Now I'm going to just bring this one straight over because I will have 7x plus 7y is equal to 63, and when I add them, my x's will go away because -7 plus 7 is 0, so we'd have 0x. -56y plus 7y will get me -49y, and -112 plus 63 will get me -49. So I'm going to divide both sides by -49 so I can solve for y. So my plus cancels, so does my 49, so y will equal 1. Because -49 over -49 is a positive 1. Now all I have to do is sub my 1 back into one of my equations. I'm going to sub it up into the original because I want to solve for x, and it's a single x, and then I wouldn't have to divide by 7. So I'm going to get x plus 8 times 1 equals 16, because I just plugged the 1 in for the y. So this will get me x plus 8 equals 16. Subtract 8 from both sides, and you get x equal to 8. Now, when you finish these, you have to put them in an ordered pair. Put the x first because x comes before y in our ordered pairs. So you have a value of 8, 1, and that would be your solution. Doing the same type of thing with systems of linear equations, we have a story problem. This one will be similar to 39 if you're in my class working the review. So we have the Family Fine Arts Center charges $25 per adult and $13 per senior citizen for its performances. On a recent weekend, its performances, a weekend evening, when 475 people paid admission, the total receipts were $8,635. How many who paid were senior citizens? Well, you got to set up two linear equations. So the first thing that we want to do is take note of what we have. So we have some prices that are happening here. We have $25 for adult and $13 for senior citizen. And we have 475. So 475. You could say that people paid, basically then they bought tickets, right? Because that's $25 per ticket. So 475 tickets or people, either way you want to look at it. It's up to you what you want to call them. And then you have a total amount of receipts. So then we have $8,635. So what are we going to do for this? Well, we got to pick some variables. So I'm going to pick x and y because that's the common ones we use. So I'm going to say x equals this and y equals this one. So if we're looking for how many who paid were senior citizens, we want to solve for the y value. So how do we do this? Well, we have 475 total tickets that were sold or people that came. So that's going to create an x plus y equals that total of 475. Now we have prices that go with each of those. So we're going to have 25 times x plus 13 times y will equal our total of 8,635. So now we're doing the same thing we did on the previous problem. We have two equations and we need to figure out what we want to do. We want to solve for y, so we want to eliminate the x. So what I'm going to do is multiply both sides by -25 because I need the opposite sign to subtract there. So that means I'm going to get -25x minus 25y equals -11,875. And then I'll bring down the other equation. So 25x plus 13y equals 8,635. Well, those will cancel. So this will leave me with negative 12y is equal to negative 3240. We'll divide both sides by negative 12. And that'll cancel the plus or the minus signs, the 12, and we'll get y is equal to 270. So how many senior citizen tickets were sold? 270. Now, if you had to solve for both parts, so you also had to solve for the adults, you could then take this 270, you can plug it back into the equation, which will basically cause you to subtract it from 475. So you would end up with 225 of those.